In this lesson, we're going to learn how to graph linear functions that are written in slope-intercept form. Slope-intercept form is an equation that has the form y equals mx plus b. M is a number that represents the slope. This tells us the steepness and the direction of the line that we're graphing. B represents the y-intercept, where the graph passes through the y-axis. We can use this information to graph a line. Let's take a look at some examples. Suppose we want to graph the function f of x equals 1/2 x minus 3. First, it's important to remember that f of x means y, so we're really graphing the line y equals 1/2 x minus 3. The number in front of the x is the slope, 1/2. That means our movement will be up 1 and right 2. The -3 represents the y-intercept. This is where the graph will pass through the y-axis, and this is what we will use as our starting point. When we begin our graphing, we start with the point at -3 on the y-axis. This is the y-intercept. Next, we use the slope to plot additional points. Our slope is positive 1/2, which means we're going up 1 and then right 2. Again, we'll go up 1 and right 2. And we continue to follow this pattern to plot additional points on the graph. If we go back to the y-intercept, we can follow that pattern to plot additional points on the left. Instead of up and right, we can go down and back, down and back, down and back, and plot additional points. The more points we have, the more accurate our graph will be. We connect the points carefully with a line, arrows on both ends, and we always label the line with the equation. Here, f of x equals 1/2 x minus 3. This is the graph of the linear function that we were given. Notice that the slope is a positive number, 1/2. When the slope is a positive number, we will have a linear function that is increasing. Increasing functions have positive slope. Let's take a look at another example. In our next example, we want to graph the function y equals -3x plus 6. Here, we see our slope is -3. Remember, -3 is really -3/1. That means our movement from point to point will be down 3 and right 1. The negative simply tells us to move down instead of up, and we always move to the right. The y-intercept is 6. This is where we'll begin on our graph. We plot the point 6 on the y-axis. Now we use the slope to plot additional points. The slope is -3/1, so we go down 3 and to the right 1 and plot the point. Again, down 3, right 1, and plot the point. We repeat the process, down 3 and right 1, until we can't fit any additional points on our graph. Then we connect the points with a line, arrows on both ends, and we label the graph with the equation. Notice that the slope is a negative number, -3. When the slope is a negative number, we will have a linear function that is decreasing. Decreasing linear functions have negative slope. Here's an example for you to try. Can you construct the graph of the function f of x equals -2/3 x plus 1? Please pause the video here and come back when you're ready to compare your answer. Let's see how you did. We have a function in slope-intercept form. The slope is -2/3, and the y-intercept is 1. We begin by plotting our y-intercept at 1, and we use the slope -2/3 to plot additional points by moving down 2 and to the right 3, down 2 and to the right 3. We can then plot additional points by following the pattern backward going up 2 and back 3 on the other side. We connect the points with a nice straight line, label the graph with our equation, and we're all done. Here's one more for you to try. Can you graph the function y equals 3x minus 5? Please pause the video here and come back when you're ready to compare your answer. Let's see how you did. We see in this problem that we have a slope of 3, or 3 over 1, and a y-intercept at -5. On our graph, we start by plotting the y-intercept at -5, and then we move up 3 and to the right 1 to plot additional points. Once we've plotted the points, we connect them with a nice straight line, arrows on both ends, and we label the line with our equation. This is how you graph functions that are in slope-intercept form. It's important to note that if an equation is given to you that's not in slope-intercept form, that you must rearrange it so that it is before you can graph it. This is everything you need to know to get started graphing linear functions. You can learn more about linear functions in Mr. Dorey's Algebra Handbook, available at www.doreypublications.com.